Okay, so we're doing question number 10 on the worksheet on forces on threaded ring. A smooth ring R of mass 0.16 kg. Okay, so smooth ring means that the tension on both sides here and here would be the same since it's a smooth ring. So this outwards would be T and this would also be T, not T1 and T2. If this were not a smooth ring, we would have used T1 and T2. Okay. And then the mass is 0.16 kg. That means the downward force here is going to be weight, which is mass times 10. So 1.6 newtons. Okay. So mass of 0.16 kg is threaded on a light inextensible string. The ends of the string are attached to fixed points A and B. Horizontal force of magnitude 11.2 acts on R. Okay, we can see that here. In the same vertical plane as A and B, the ring is in equilibrium. Okay, that means the up forces acting on R is equals to the down forces acting on R, and the right forces acting on R is equals to the left forces acting on R. The string is taut and angle ARB is 90 degree. We can see that in figure as well. And part AR of the string makes an angle of theta degree with the horizontal. We can see that in the figure. The tension in the string is T newtons. Find two simultaneous equations involving T sine theta and T cos theta. All right, so we're going to resolve the two for tensions that we see. For this one of the component would be in this direction and the other component would be in this direction. This would be theta from alternate angles. Okay. And then we know that this component here, which is the adjacent component, is actually the cos component. I'm sorry. So this is going to be T cos theta. And the one upwards is opposite to theta. So that's going to be the sine component. But I'm going to make sine component over here. So this will be T sine theta. Okay. Now let's take a look at the string RB, which is pointing in this direction. So we can have a force, if we're resolving it in this direction, then a force will be towards the left and one component of the force would be downwards. But if you plan to resolve it here, then it's going to be downwards and leftwards, which is actually the same thing. Okay, now what I need to do is somehow map this angle theta or this angle theta onto this lower triangle. Okay, now how do we do that? We know that this angle here is theta and total angle here is 90, making this 90 minus theta. So this part only, this part is 90 minus theta and this would be 90. The component which is horizontal and component which is vertical is 90. And then this would be equals to what? Let's see, 180 minus 90 minus bracket 90 minus theta, which is just theta. So this is theta, which means that this angle here is the same as this angle here. Okay. Now, the angle opposite to that is going to be T sine theta. So, opposite in this direction would be T sine theta. And this downward one is going to be T cos theta. But I am plotting it here instead, downwards. T cos theta. Okay. Now we equate these. So we know the forces on the left, which are these two forces, T cos theta, T sine theta, should be equals to the force on the right. So 11.2 is equals to T sine theta plus T cos theta. And the up forces should be equals to the down forces. So there's only one up force, T sine theta, and there are two down forces, 1.6 and T cos theta. So T sine theta equals 1.6 plus T cos theta. This should be answer for part 1. Let me quickly verify. Yes, that is correct. Both these equations are correct. Part 2 says hence, meaning using these answers, find the value of t and theta. Okay, so I am going to replace sine theta here with this. So we're using substitution. So 11.2 is equals to 1.6 plus t cos theta plus t cos theta. So 11.2 minus 1.6 is equals to 2t cos theta. Oh, that's the problem. That's giving me both t and theta as t and theta, yeah, as variable. So let's see if we can work this out. Okay. So we're not getting a single variable. How do we get a single variable? What can be done? I think we need to make t cos theta and t sin theta subject and then somehow change it into uh, tan theta. Let's see if that works or not. Okay, so this is giving me 11.2 minus 1.6 divided by 2, 4.8 is equals to t cos theta. Okay, now I'm going to try and make t sin theta the subject. Let's do that here. So t sin theta would be equals to 1.6 plus t cos theta, which we just found, which is 4.8. So t sin theta equals to 6.4. Okay. Now we can divide these. I'm going to do t sin theta upon t cos theta equals 6.4 over 4.8. So tan theta equals 4 over 3. So theta is equals to shift tan 4 over 3, which is 53.1301, 53.1 degrees. Okay. Then we have to find the value of t, so we could use any of the equations that we found already. Let's use this. So we have t times sine 53.1301 is equals to 6.4. T is equals to 6.4 over sine 53.1301. So I'm doing 6.4 divided by sine answer, which is giving me exactly 8. So tension is equals to 8 newtons. So by using the answer key in the calculator, you can avoid premature rounding and you get an exact answer of 8 newtons.